Alright, so here we are with Unit 6, Lesson 1. And Unit 6 is entitled Physical Behavior of Matter, which we're going to abbreviate PBOM. So let's take a look at the first slide. Now, the first few slides are really just a review of what we had done in Unit 1, taking a look at matter. And matter, if you remember the definition, is anything that has mass and takes up space. And matter can be broken down into two subcategories. The first one would be substances. And substances have a definite composition. In other words, the composition of a substance never changes. They're also considered to be homogeneous. The other one would be mixtures. Mixtures do not have a definite composition. Now, what do we mean by that? Well, you could have a mixture of sand and salt, but with different ratios. You know, in one mixture of sand and salt, you might have 50% sand and 50% salt. In another mixture of sand and salt, you could have 75% sand and only 25% salt. And that's the difference, one of the differences between substances and mixtures. And this is going to continue on the next page. Mixtures can be separated physically by using physical means like filtration, distillation, etc. And mixtures can be separated into substances. So you could have a mixture of two elements or two compounds or any combination of the two. Next would be breaking down substances. Substances can be broken down into two categories also. Elements, which you know all the symbols of the elements are on your periodic table. And the other subcategory of substances would be compounds. In order to make a compound, you have to chemically combine two or more different elements. Elements can be chemically decomposed or separated into elements. Elements cannot be decomposed chemically. Elements can be individual atoms. Compounds can be either ionic, which means you have a metal and a nonmetal, which is a review of the unit on bonding, or you can have molecular compounds, which are composed of only nonmetals. So this is really just a review of a couple of the previous units. A couple of questions here just for you to check to see if you understand. It says a compound differs from an element in that a compound, well, both elements and compounds are homogeneous, so A is not the answer. They both have a definite composition. They both have a definite melting point. The only thing that's different between an element and a compound in these four is that compounds can be decomposed by a chemical reaction. Elements cannot. Which of the following substances cannot be separated by chemical change? Well, we already know that that would be elements. The only element listed there is nitrogen, letter A. Alright, let's continue our classification. Now we're going back through mixtures. So there are two kinds of mixtures. There are homogeneous mixtures, which are called solutions, and there are heterogeneous mixtures. We really don't talk much about heterogeneous mixtures. I think probably the best thing is to look at an example of what a heterogeneous mixture would be. Heterogeneous means that the components of the mixture, the parts of the mixture, are not evenly distributed. For example, if I took a beaker of water and put sand in it, that would be considered a heterogeneous mixture because the sand literally doesn't dissolve in the water, basically just sinks to the bottom. So the sand is not evenly distributed throughout the column of water. That makes it heterogeneous. On the other hand, a homogeneous mixture would be if I took another beaker of water, but instead of sand, I put salt in the water. Now, because salt dissolves in water, that would form a homogeneous mixture, or what we would call a solution. A pure substance that is composed only of identical atoms is classified as, well, that would be an element if it's composed of identical atoms, because a compound is not composed of identical atoms, it would be at least two different atoms. A heterogeneous material may be, only mixtures can be heterogeneous materials. Both elements and compounds, which are substances, are homogeneous. Alright, so let's look at how we separate matter. If you have an element that's a monatomic element, as opposed to the Brinkelhoffs, which are the diatomic, they cannot be decomposed or broken apart using chemical or physical means. So if you have an atom of iron, there's really nothing you can do to it chemically to break it down into smaller pieces. If you have a diatomic element or even a compound, they can be decomposed by chemical means. So for example, if I have an oxygen molecule, which is O2, I can split the oxygen molecule and get two separate oxygen atoms. I can do the same thing to a water molecule. I can separate the H from the O in a water molecule chemically. And we'll get into that when we do one of the units on electrochemistry. So let's just quickly run through. Mixtures can be separated using physical means, and here are some four of the most common physical ways or physical means of separating Mixtures, we did this in a lab. Filtration, we had a mixture of sand and water. If you pour that mixture through the filter, the sand will get trapped in the filter. This generally works for heterogeneous mixtures. It doesn't work for homogeneous mixtures. Evaporation is actually, this is incorrect. This should be separation by boiling point is actually distillation. Let's go through all of these. Yeah, this should say separation. Well, I guess it is correct actually, because if you have evaporation, you have two liquids. I guess you could say that, but evaporation is generally used when you have a heterogeneous mixture. Like if I had sand and water. Now I know the sand doesn't dissolve in the water, but if I let that beaker of sand and water sit out, all the water will evaporate, and what will be left in the beaker is just the sand. So technically I have separated them. Chromatography is a lab that we will do in the unit on solutions. And distillation is something we'll talk about when we use solutions also, but also in the unit on organic chemistry. And it looks like there's a video, so let's take a look at this video. Let's get rid of the commercial. Okay, so what we have is four different inks, and they're just sitting in a very small amount of water. Notice what's happening to the inks. It looks like the inks are being pulled away from the center, and that is due to the polarity of the water and the inks. And notice this one here, which is the most obvious. Look at how it's being separated into its different components. Now why is that? Well, because some of the ink components, whatever the colors are less or more polar than water. So the water molecules are pulling the more polar molecules further away from the center. And we'll do this also in a lab when we do solutions. Okay, and let's go on. Check for understanding. Which of the substances could be decomposed by a chemical change? The only substances that can be decomposed by a chemical change are compounds, and the only compound there is ammonia. You will not find ammonia on table S. Remember, table S only actually gives you the symbols and the names of the elements. So if you're not sure which of these is an compound, just look for the one whose name does not appear on table S. A sample of a material is passed through a filter paper. A white deposit remains on the paper, and a clear liquid passes through. The clear liquid is then evaporated, leaving a white residue. What can you determine about the nature of the sample? Well, this is similar to what we did in the lab. It's definitely a heterogeneous mixture, because heterogeneous mixtures are separated using filtration, so we know that's the case. Alright, let's go through the phases of matter. Again, this is just a review. These are called particle diagrams. You should understand and be familiar with them. Here's the difference between what a solid, a liquid, and a gas. Notice the only difference between substances that are in the solid, liquid, and gas phase is the distance between the particles. Going from a solid to a liquid or a liquid to a gas, these are all physical changes. So when I go from, for example, ice and melt it into liquid water, that's a physical change because the composition hasn't changed. It's still H2O. It's just the molecules are moving further apart. Notice what happens when you go to a gas. The molecules are the farthest apart. Last slide, let's look at the different types of mechanical energies. The two that we use in chemistry are kinetic and potential. And kinetic is basically for our purposes, kinetic energy and temperature are the same thing. It measures how fast atoms are moving. The faster the atoms are moving, the more kinetic energy you have. The other one would be potential energy. And for us in chemistry, potential energy is synonymous with, or meaning the same thing as heat. But you cannot measure potential energy directly. You can really only measure changes in potential energy. And that's it for Unit 6.